All right, our recording is on. So welcome everybody to our webinar. We're going to talk a little bit about Ohio Valley weather hazards today. My name is Joe Sullivan. I'm the Warning Coordination Meteorologist at the Weather Service here in Louisville. Without further ado, let's see if I can get there we go. Start off with a question. What do weather and real estate have in common? Now, when I do this presentation in front of people, I expect people to answer back, but in this case, I'm not going to, sit here and wait for people to answer. It's sort of a rhetorical question anyway. If you've ever bought a house and worked with a real estate agent, what they say is there's the top three rules in real estate is location, location, and location. And so what we're going to talk about today is where we live in the Ohio Valley, the location of our homes right here in the eastern part of the United States on the northern hemisphere, how that affects thunderstorms, tornadoes, floods, flash floods, heat, and winter weather that affect us all to one degree or another throughout the year. So just a quick little look at our planet. If you take a look at the spinning globe, you can see that right here at the equator, it's a big, hot area there, and most people know that it's going to be hot down at the equator. It's cold up in the northern hemisphere, and where we happen to be is about between, Louisville's right at 38 degrees north, so we're not quite halfway up, but being that far away from the equator, we do get all four seasons in through here, so that's the first thing to look at. And then as we look at the geography of the United States where we are, and you can again see the U.S. goes from 30 degrees north to approximately 50 degrees north, and where we are right here in the Ohio Valley is about halfway between those. So we're sitting right at about 38 degrees if you ping on Louisville. But just as important as how far north we are on the planet is what sort of terrain we have around us. And you can see the mountains out west, and this is a false colored image based on the elevation, but the colors are selected to sort of represent the type of topography and colors you would see if you were taking a color snapshot from a satellite, and that it's much greener down where you have much more moisture falling down near the Gulf of Mexico, where the elevations are just a little bit above sea level, and then as you get out of the Rocky Mountains, you got snow-packed peaks that last year-round. And where we are here, you can see low enough elevation that we do get a lot of moisture. Looking at the geography of the state of Kentucky and southern Indiana, we can see that because I don't have the whole state of Indiana, I didn't put the elevation differences in there, but for Kentucky, there's quite a geography elevation change from the low point in the state, which is only 260 feet above sea level, to Black Mountain on the eastern edge of the state on the border of Virginia, where we're over 4,000 feet, so almost a mile high, or 3/4 of a mile high by there. And you'll see as we go along here that elevation definitely does make a difference, land use, elevation, etc., when it comes to things like thunderstorms and tornadoes. So briefly, with thunderstorms, we have three ingredients that we deal with. The first ingredient is moisture. You can't have thunderstorms without moisture, and moisture is humidity. And where we sit in the Ohio Valley is right here. So we're looking for a moisture source for our weather. And we've got several large moisture sources around here, so we're going to take a look at some of these. The first one is right up here to the north. That's the closest one to us. And you might think that we pick up a bunch of moisture up there, and that's where we get our first ingredient for thunderstorms. But in all reality, the flow from the north is not really conducive to getting us a lot of moisture in here for thunderstorms to develop. We get more of our northerly flow in the wintertime, and we have had snow. While we don't have lake effect snow like they do in Cleveland or in Buffalo or even in parts of northwest Indiana off the lakes, Great Lakes up there, we just don't get as much moisture that can make it down this way. But we do have the northerly flow that can pick up a few flurries for us or maybe an inch of snow on some occasions. But really, the warmer and larger oceans are a much, much better source for thunderstorms for us. Now, we live in a part of the planet that is known as the prevailing westerlies because our weather systems go from west to east. So let's take a look at the Pacific Ocean, the giant source of moisture out there. Is that where we get all of our moisture for our weather? Well, even though it's to our west and things move from west to east, we have this big thing called the Rocky Mountains. It serves as sort of a wall that blocks all the moisture from coming over here. So that's not what where we get our precip. So let's take a look at the Atlantic Ocean on the other side, much, much closer. But even though they're not nearly as tall as the Rocky Mountains, the Appalachians do act like a big old wall there too. So we don't get a lot of moisture coming from the Atlantic Ocean over the Appalachians to affect us here in Kentucky and southern Indiana. And if you need just an example of that, think about Hurricane Florence a couple of weeks ago. Hurricane Florence hit in the Carolinas, caused all sorts of flooding problems out there. They had some locations that had 35, 36 inches of rain. And I think we picked up, how much did we get, Tom? Maybe an inch at the very most here in Louisville. Well, just a few weeks earlier, the remnants of, was Gordon ever a hurricane or was it just tropical storm? Tropical storm Gordon, which was down in the Gulf of Mexico and came up through this nice Mississippi Delta here, brought us 6 and 7 inch rainfalls one night in Louisville, and resulted in, if I'm not mistaken, 3 different fatalities. There was a fatality associated with Gordon, with the heavy rains from Gordon that occurred when a 15-year-old student was slipped and sucked into a stormwater drain, and then also there was a cab driver in Louisville who literally drowned in his vehicle after he became submerged. And then there was another one out to the east of us in the Jackson County, Warren area that I'm not as familiar with. I think it was in Rowan County. Another tragic case where a youngster fell into a flooded area. Okay, so that's the moisture that we get primarily coming from the Gulf of Mexico for our big thunderstorms. Second ingredient that we need for thunderstorm development is something called instability, and I like to use my Introduction to Dynamic Meteorology. People save books from college anticipating using them later in life, and I can prove that I use mine later in life by showing you how stability works. With an unstable book, if I give the book a little push, it continues going in the direction that I pushed it. With a stable book and environment, it's the opposite. Here, a little push, and it keeps going in the same direction. Unstable. Now stable, I pull it up, but when I stop forcing it upward, it goes back to its original position. So unstable, little push, keeps on going. Stable, doesn't matter how big the push is, it's going to go back to where it started. So when we look at the atmosphere instead of a book, the atmosphere that is the air mass that is the most unstable is a warm, moist air mass near the surface. Warm because warm air rises. You might remember that from when you watched hot air balloons rise. Cold air balloons don't rise. In fact, I used to be a hot air balloon pilot when I lived out in Wyoming. And moisture, when you add moisture to the air, it actually reduces the weight of the air, which seems sort of counterintuitive, but basically the moisture molecules take up more space, but don't. They're lighter than the molecules that are supplanted in an air mass that does. So cooler air is heavier. That's why cold air falls, and drier air is heavier. And when those are aloft, then you got the warm, moist air that wants to rise up into those things. And when you put it into a picture with the atmosphere and what it does not only for a hot air balloon, but when you have warm, moist air rising, then the moisture in the air, as it gets up to the cooler temperatures, cools off to form clouds and rain and hail and snow, et cetera, et cetera. Okay, now the third and final ingredient for thunderstorms is what we call a trigger or lift. And the 4 main ones that we look at for thunderstorms especially are the convective lift, which occurs when you have, say, a black surface is going to heat up faster than a grassy green surface around it, so asphalt will heat up faster. and it starts to rise just like the hot air balloon, and it's supplanted by cooler air that comes in and fills in around it. The next one is frontal, cold fronts and warm fronts. Cold front is when you've got a cold air mass that is pushing into a warm air mass, and it wedges itself underneath it and forces the moisture up. A warm front looks a little different, but it's the same with the way that the structure of the front is, but it's warm air mass is pushing into a cool air mass, and it rises up, and you get the same sort of thing with clouds and rain forming. The next one is what we call orographic lift, and that basically means that when you have wind blowing toward a large change in elevation or mountains, the wind can't blow through the mountain, so it has to go up. As it goes up, the moisture in the air condenses because the temperature cools as you go higher in the atmosphere. If you've never flown in a hot air balloon, but have flown in a small airplane, you know that when you get higher in the atmosphere, the temperatures are much colder, and that's what happens just as the air rises, as it's being forced upward by the mountain. So the moisture condenses, and the precipitation falls out on the upward side of the mountain. On the downward side of the mountain, you have descending air, and it warms, and so it dries. And I used to live in Cheyenne, Wyoming, and I can guarantee you that Cheyenne is a perfect example of this, because it's a desert, technically, with the amount of moisture that gets each year, only about 7 inches, while Jackson Hole in Wyoming on the east, or on the west slopes of the Continental Divide, gets somewhere about, they get several hundred inches of snow alone. So they're more, they get much more moisture, and you typically get more vegetation on the west side of mountains, or I should say the windward side of mountains, than you do on the leeward side. The last one is just convergence. When you have outflow boundaries from a couple of different thunderstorms, when they intersect, and we see this all the time on radar, when intersecting outflow boundaries come together, then you get new development along that, because when the air comes from a couple of different air locations and runs into each other, it can't go down into the ground. It can only go one direction, so it goes up, and that forms a thunderstorm. Let's go back to our U.S. map now and to look at geography and terrain, and see how those two, when you look at the low-level moisture, the green areas where we have lower elevation and more rainfall, that's where we get much more lightning. That's because you've got all the ingredients for the thunderstorms, and thunderstorms are, by definition, have lightning in them. It's the lightning that creates the thunder. So you can see that the peak location for lightning in the U.S. is down in Florida. That's because it's surrounded on 3 sides by water that provides that first ingredient every day of the year for thunderstorms. And then as the differential heating, as the land heats up more than the ocean, you get the sea breeze comes in, and they get afternoon thunderstorms almost like clockwork. Same sort of thing happens out in the mountainous areas of the Front Range too. But lightning is much more common in the lower elevations. And, not surprisingly, damaging wind from thunderstorms is much more common in the lower elevations too, because that's where we have the peak of the thunderstorms. Now, looking out to the west, if anyone has ever lived out there, they know that Wyoming is a very windy location, but the wind is it's a different type of wind, so to speak, in that it's not from thunderstorms, it's just from what we call gradient winds, and also because the mountains are sticking up several thousand feet into the air, and stronger winds occur higher in the atmosphere. Looking at hail reports from across the United States, there is definitely a peak in the Central Plains, and that goes along with tornadoes as well, because of the fact that you get all the ingredients that you need in the central U.S. Think of I'm going to go back a couple things here, but if you think of the central U.S. as being sort of a bowl with the mountains to the west and the east being the edges of the bowl, right in the central part of the U.S. here is where you've got all the ingredients you need in that bowl, and one of them is the moisture that you need to develop the large thunderstorms that produce hail. Now, when it gets to tornadoes, it's the same sort of thing. You put this on with the geography map, and you can see that thunderstorms that produce tornadoes typically occur in the lower elevations, not nearly as much in the mountainous areas, although tornadoes have occurred in all 50 states, including Alaska and Hawaii, You just see that there's just not nearly as many occurrences there or in the Appalachians. Surprisingly, even though the mountains are not that high here, they do suppress the tornado formation, in part because of the flow of air that can occur in and around the mountains. It's diverted by the terrain. Now, that doesn't mean you can't have, that with big mountains you can't have tornadoes. That's not the case at all. And in fact, this little tornado that you see up near Yellowstone in Grand Teton National Park was at over 10,000 feet elevation back in the 1980s. This is the reason that the large supercell tornadoes occur mostly in the central U.S. You've got the moisture, but you also have the ingredients in the wind direction and wind speed at different elevations. The low-level winds in the types of tornadoes that we call supercells that produce the biggest tornadoes, you need to have southerly winds in the low elevations, and then a more of a west to northwest flow aloft, and that gets the rotation going. And it just happens that in this part of the country you have all those ingredients. Now, there was a story that came out yesterday, a research paper that was published in Climate and Weather, I think, talking about how this is the traditional tornado alley here, and there's variations on it that have eastern Kansas in there as well, and Oklahoma and more of Texas. But this is regardless of where you put it, the high plains up through the northern Mississippi Valley is generally considered tornado alley. For large tornadoes, that's pretty much still true, but there are other widespread areas, including what's known as Dixie Alley down through the southeastern United States. And actually, over the last 20 to 25 years, the deadliest tornadoes have all been within about 100 to 200 mile radius of Memphis for a number of reasons, including the fact that the southern U.S. tornadoes that occur typically happen in the winter season, and when the cold air from up north is colliding farther to the south, and you get that the abrupt change of warm to cold air that provides greatest instability, and it also has the warm, moist air with it. But because tornadoes that occur in January happen on days that we have considerably less daylight, that means that a large number of them occur after dark, and seeing tornadoes after dark is virtually impossible without lightning. And so nighttime tornadoes are the biggest killers because people can't see them coming and don't know what's hitting them. Okay, let's look at the supercell tornadoes. Supercell tornado has this thing that we call a hook echo, and here's the hook right through here. Let me see, I'm going to try something. I don't know if you're seeing the mouse or not. I'm going to use an annotation here, just do that. So, oops, didn't work, okay. So much for that. Hopefully you're seeing my mouse. If somebody wants to just chat in the box there and let me know if you're seeing oh, there, that's what I wanted. I wanted to show the, it doesn't look so great. And it says some people can't see annotation, so I'm going to take that off. Sorry about that. Let's get rid of that. Oh, it's still on. Okay, well, you can see the mouse. This is the hook that gives a hook echo its name. And what's happening here is this is the rotation of what we call a mesocyclone, a small cyclone, and everything that's cyclonic in the northern hemisphere rotates, when viewed from above, rotates in a counterclockwise fashion. In these big supercell storms, the precipitation is all occurring up through here. Some of it can get wrapped around on the backside, but the rotation in the supercell is under the updraft, and that's on this side of the storm. And when we look at a diagram of what it's like, some of that gets wrapped around. You got the warmer wrapping in here. It's like a mini cold front, and it's wrapping around an intense low pressure system, which is the low right there. Now, the thing about supercells is they can produce damage not just from the tornado, which is a very small thing, even though you get really big tornadoes that are up to a mile wide. When you look at the whole planet, that's pretty small still. But the widespread wind that can come from a downdraft from a big thunderstorm takes up a much larger area, and that's why when we issue our tornado warnings, they don't cover small areas like this. they cover the entire storm, because you can have large hail up to baseball or softball size with the storms that produce tornadoes, and that can be just as deadly as the tornado. And then you can also get the outflow boundary with winds there and the rear flank outflow boundaries there. So that's why when we issue our tornado warnings, they are issued much larger, as this red box shows you, than any tornado. There's never, ever been a tornado on this planet that's as wide as one of our tornado warnings. So they're very, very small, but the other threats, the wind and the hail and the heavy rain that occur with these supercells, warrant people being warned for those as well. Okay, now in the Ohio Valley, we're in sort of a transition area. The tornadoes that occur around here are typically not, and I can't emphasize that enough, they are typically not the types of things that you're going to see on the Weather Channel or seeing Reed Timmer chasing around. And those supercell tornadoes out in Oklahoma and Kansas and the High Plains and Texas, those are the ones that generally get up into the, we rate them on a scale called the Fujita scale, the enhanced Fujita scale, and those are the ones that get up into the AEF 2, 3, 4, and 5 ranges. Most of the tornadoes, actually across the entire United States, never get into the EF2 category. They stay in the EF0 and EF1 category, which are winds somewhere between 60 and 110 miles an hour. Now, a lot of the tornadoes we get around here are not supercell tornadoes, but they occur with a squall line. And when we have breaks and bends in the squall line, you can get rotation with those. And usually those result in tornadoes that are EF0 or EF1 intensity, again, below 110 miles an hour. Now, just because they're considered weak tornadoes doesn't mean that they're not dangerous, obviously, but they just don't do as much damage, because a 200-mile-an-hour wind with an EF5 tornado is going to literally destroy homes and destroy buildings or even some well-built buildings, unless you have a concrete shelter. But if you're worried about your own personal safety, a 70-mile-an-hour wind can kill you. And if you don't believe me, try putting your head outside your window as you're driving down the interstate at 70 miles an hour and hitting a road sign or hitting a tree. It's going to hurt you, or it's going to kill you, especially if it hits you in the head. So let's take a look at the breaks and bulges. Everybody's seen a squall line on television, probably, but the squall line itself is not always dangerous. It's going to bring winds that, if you're outside, and especially lightning, could cause some minor damage. But when you see these big bulges in it, this is occurring because the stronger winds are pushing the storms farther and farther out. And frequently you'll get this thing called a shelf cloud on the leading edge, and we get photos through social media. We see a lot of shelf clouds. I've been in this business for over 30 years, and when I was a young pup meteorologist back in Kansas and Nebraska, the old-timers at that time told me that when you see a shelf cloud, a good rule of thumb is to add 30 miles an hour onto the speed of the storm, and that's the peak wind that you'll probably see. So if you've got a storm that's moving through at 30 miles an hour and you see one of those big, strange-looking shelf clouds, I should have put a picture in here, but I can try and find one for you after I get done. In fact, I'm going to do that right now. I'm on my other screen here, shelf cloud, and I'll show you some shelf clouds real quick here. There we go. Bring this across. These are what I'm talking about, these big horizontal clouds. They're sort of scary looking. They're not the normal looking clouds you see, and because they look scary, people think they're a lot more dangerous than they are. While I'm not going to say that they aren't dangerous, the speed of the shelf cloud movement is really what you're concerned about. And if a storm is moving through at 40 miles an hour and you see a shelf cloud, the rule of thumb that I learned 30 years ago is add the 30 miles an hour on. So 45 miles an hour storm movement with a shelf cloud is going to give you 75 mile an hour winds somewhere along the shelf cloud. It might be right here, it might be right here. Don't know the exact location, but somewhere they're going to be hurricane force winds. A storm that's moving through at 25 or 30 miles an hour, the shelf cloud is going to be putting out winds that get right at the threshold for where we start to see tree damage and minor roof damage with with shingles, and that's going to be closer to 60 miles an hour, 58 miles an hour. Now, on the north and south end of a bulge like this, you get rotation just because of the way that the storm is moving around, and this bulge helps, and the line helps create this rotation on the north end, the bookend vortex. You get one on the north and one on the south. The ones on the south side of these bulges tend to weaken out because they're going clockwise, the opposite rotation of what a low pressure system in the northern hemisphere does. So these tend to fade out, while these can produce what we call squall line tornadoes. And the squall line tornadoes are the most common type of tornado when you get into central and eastern Kentucky. Especially in central Kentucky, we have a lot of these. This is an example from an outbreak in 2008, the February 5th and 6th Super Tuesday outbreak, when we had 26 tornadoes in the state. Of the 26 tornadoes, 4 were supercells and 22 were squall line tornadoes. Now, looking at this, you really wouldn't see much other than you've got some breaks in the line, like right there. But when you look at the velocity scale that goes along with it, green is going toward the radar, which is up here at Fort Knox. Red is going away from the radar, and wherever we had one of these little red-green couplets, on this particular day, we had a tornado that touched down. Now, we also had a lot of straight line winds that day that occurred because the storms were moving through at 50, 55 miles an hour. And when storms are moving at 55 miles an hour and you have a shelf cloud, that's giving you an 85 mile an hour wind. There was probably more damage on that particular day from straight line winds than there were from tornadoes, just in the sheer numbers of trees that were down and buildings that were damaged and stuff. But the most intense damage did occur with those tornadoes. Okay, let's move on now to floods. And the first type of floods we're going to talk about are river floods. This is the Ohio and Mississippi confluence just across, you can see Cairo, Illinois, just across from Kentucky. And literally where you're supposed to have a little bit of water, this is down near Boston on the Rolling Fork River, you have miles and miles. It turns into an ocean. And just right here in Louisville in February, we had one of the highest crests in one of the top 10 crests on the Ohio River. This is down near the Yum Center, 3rd Street, coming down there if you're familiar with that. So we all know about river flooding in this part of the nation. River flooding typically occurs in the springtime. And there's a big difference between the floods that we get, or the level of water rise that we'll see on these rivers in the springtime with a set amount of precipitation than we will later on in the year. And the big difference is caused by the fact that if you've got rain falling on vegetation that's not growing, it runs off pretty quickly. When there's no leaves on the trees, when the ground's cold, maybe not frozen, it's all going to run off into the rivers. So when we get heavy rains in the springtime, we have more river flooding than we do, say, with the September heavy rains that we had, where we get more flashy flooding, but not as high a rise on the rivers. There are a lot of rivers in Kentucky. I don't have the Indiana ones on this one. Apologize for that. But the rivers that you see here are all big enough to have sustained flooding that can cause damage, primarily for people who are a little too close in the floodplain. The flash flooding issues that we have, though, are extremely dependent on elevation for the most part, and wherever you have a change in the elevation, especially out in eastern Kentucky, you have a high risk of very rapid water rises. These are the sort of wall of water types of things that we run into. But it doesn't have to be a wall of water in eastern Kentucky. In fact, this is in Nat Rogers Road, south of Bardstown in Nelson County. This is what it looks like on Google Earth or Google Maps. Just a little creek that goes through there, not much of anything most of the time, but because the elevation dips like this and it all comes down very quickly in heavy rains, this is what can happen when water rushes through there very quickly. You can get water that comes up over the road there, little little creek turns into a wall of water for a very short period of time, and if you're in a vehicle in the wrong location at the wrong time, you can lose your life. And with this one, this is in western Kentucky, not near the rise, but there's a lot of, because the water levels are usually lighter out there, and because it costs so much to put a bridge in many rural areas, there's no bridges over these low water crossings. And if you've been in rural Kentucky, you've seen them. They're all over the place. There's just concrete and a little water goes over it, and normally you can drive through that. But if you drive through at the wrong time and the water level's up here and it's 4 feet of water, that's how you lose your life, and that's what happened in that case. Here's an extreme example from the same day that the Nashville flooding occurred back in 2010, May of 2010. See this pickup here, notice the water level on it, small pickup like an S10, I think. The water's supposed to be over here. This is a road right here, but it's spread clear out, several hundred yards away from the bridge, and the bridge goes out considerably farther from where the creek there is supposed to be. And in this case here, this guy was driving through and got washed off and butted up in the ditch there. These are firemen from Allen County who went out to rescue him. Notice how high the water is now. By now, the water's already coming up over the windshield, and it's covered the box of the truck. And this right here is a fire truck ladder that's intended and designed to go up. So these guys know what the limits are, and it's probably 1,000 pounds or something like that of weight they can put on when it's going up. But this was never designed to be put out in this direction. And so this firefighter is really risking his life going out there because it becomes too heavy on this end. It could tip and he could fall into the water. When you put both of these guys on there, they're really stressing the load on this equipment. And notice that the truck is full of water by now. So this is something where they got there, they did what they had to do, and oops, got a phone call that's coming in here. Can that one. There we go. Sorry about that. And they rescued this guy in just they just had a blink of time to assess the situation and do it. And these guys were real heroes. The gentleman that was in the truck, the only injury he sustained, he had a broken arm from when the truck was slammed off to the side there. Notice in the back there that we've got a couple of other first responders that are on the other side that can't reach from that distance. Last but not least, we've got dammed up rivers. This was also the same day. This was down in Metcalfe County. This was City Lake in Edmonton, and so much rain fell there that it started overtopping the spillway, which is what the spillway's for, but it kept getting higher and higher and started eroding the outside of the spillway. And so there was a great concern that this was actually going to fail at that time. If that had, a wall of water would have gone through Edmonton on that particular day. Looking at rainfall amounts across the United States, normal precipitation it's not surprising that the closer you get to the Gulf of Mexico, the precip amounts are higher. This is showing 56 to 80 inches in through here. I mentioned the west side of the mountains typically having more rainfall than the east side of the mountains out in the Continental Divide area. And when you're right next to the ocean, there's a reason that Seattle and Portland are so wet. Looking a little closer to home in Kentucky, the farther south you go, the heavier the greater the normal rainfall is. Go up to the north by the time you get up into the Cincinnati, northern Kentucky area, under 42 inches of rainfall a year. Down around Bowling Green and Metcalfe County, down through there, 52 to 54. So a good 10-inch difference in normal rainfall across Kentucky from north to south. And then the heaviest is in the highest elevations out to the east where they get more snow. I want to look at a little bit at the 2018 precipitation. We've got 2018, this is when I put this slide together a couple weeks ago. We had already reached the 13th highest rainfall amount for an entire year in Louisville, and that was with 83 days to go. The highest rainfall amount in Louisville was just a few years ago, 2011. That was the last time the Ohio River was up in significant flooding in Louisville. But what's interesting is you throw the other top 10 dates or years precip up there, and 6 of the top 10 in Louisville, counting this year now, because we have increased. I think we've surpassed 1975, so we're very close to being in the top 10. So 6 of the top 10 will have been since the year 2000. That's a pretty significant trend that we're seeing there. Lexington, same sort of numbers. They're 13th, or they were 13th, and then 2011 was the same for them. Once they get into the top 10, it'll be 5 of the top 10 for Lexington annual precip will have been since the year 2000. This is an image that a private meteorologist in town sent me of his Davis weather station at home. Maximum rain, this was in August 16th. The maximum rain rate at 4:48 in the morning was 8.47 inches per hour. That's one of those that you can't even see across the street. It's raining so hard. And at 4:48 in the morning, you're not going to see that anyway. But we've all seen those this year. We've had some torrential downpours. This was looking back at the Gordon, Tropical Storm Gordon time frame. Notice his daily rainfall was only 2.68. That's because it didn't rain at this rate for an entire hour. If it had, it would have been a disaster. It would have been on the order of the August 2009 flooding that put Louisville underwater, and the University of Louisville had numerous buildings that were damaged from that one. Speaking of rain, I'm not originally from Louisville or from Kentucky. I'm originally from Iowa, and one of my biggest pet peeves is that people around here don't know how to drive in the snow, and they don't know how to drive in the rain. And we have so many accidents in the Louisville area, and this study that I thought this was funny just came out like a day or two before my presentation at the U of L Med Center, confirmed what we all know: Kentuckians can't drive in the rain. So we were surprisingly not the worst state. Mississippi was the worst. I think we were second or third. Okay, quick look at the weather fatalities from last year. I want to point out a couple of things. The weather fatalities in the U.S. that claim the most lives used to, years ago, be lightning. Hands down, it was lightning. In the 1940s, 400 people were dying per year. Actually, it was pretty close between lightning and tornadoes. Lightning, we've done our best job in reducing the number of fatalities per year. The 30-year is the yellow bars, 10-year average, the blue bars, and then red was just last year, 2017. So the right trend going with lightning. With tornadoes, with the exception of the year 2011, everything had been going very well, but we had a lot of tornadoes in 2011. That was a big outbreak down in the southeastern U.S., and also the Joplin tornado, I believe, was that year. That's the last tornado in the U.S. that's killed over 100 in one single tornado. There was about 160 fatalities with that. So for the most part, lightning and tornadoes were making the right trend. Heat, this is well, flood. First of all, let's go with flood. Flood is our biggest threat in Kentucky and in Indiana. More people die per year in Kentucky and Indiana from flooding and flash flooding, and then from any other of these elements that we see here: lightning, tornadoes, hurricanes, obviously, heat, winter, cold, etc. So flooding is a big concern for us in this office, and heat is also a big concern, not just for us, but for the entire country. And these bars that you're looking at here are actually misrepresentations of the heat. We're working. We're going to have a summer student working this next summer on a urban heat island problem that is an issue not just in Louisville, but in every large city. When you have elderly people who are socioeconomically on the lower end, meaning that they don't have air conditioning, or they're in an area of town where they don't want to keep their windows open, et cetera, et cetera. People who have ailments die more in the heat, and this yellow bar does capture some of those, because the 30-year average takes into consideration the huge outbreaks in 1995 and 1997 when thousands of people died in the Chicago and Milwaukee area. But they don't capture nearly as well just every year when we have temperatures in the 90s, and people that are older and have poor health, that's enough to kill them. So that's something that we're looking at this next summer, to try and look at that, how we can more accurately reflect the heat fatalities that we have in the U.S. or at least in Kentucky and the urban areas of Louisville and Lexington. Okay, it's not surprising, farther south you go, hotter, cooler up north. The heat island effect I was talking about is a real issue. It's when this is a land use image showing color showing red as asphalt and no trees, and then farther out in rural parts of Jefferson County, all within the city of Louisville Metro now, but like in Fisherville and out through there, green grass, trees, et cetera, et cetera. This is a date back in 2010, the overnight low. You can see that Standiford Field, 83 degrees for the overnight low. Bowman Field was 79, so 4-degree difference there. And then you get out farther and farther, and you get down into the 70s. So this was a really, really warm night, but there's at this point there's a 7-degree difference between the temperature and the asphalt jungle of Standiford Field or Louisville International Airport and a rural property in eastern or northeastern Jefferson County. And that actually affects our weather. So when people say that global warming or that mankind doesn't affect our weather and climate, it's just not true. Now, to the degree, we won't get into that discussion on this one, but it's a proven fact that when you heat up the air, you're going to have thunderstorms develop. And one of the things that I found out when I first moved here 12 years ago was that the heat island in Louisville, imagine this being Louisville, was causing the balloonists in town to have to adjust where they used to take off. They used to take off near the Gene Snyder and 64 out in Middletown, and they would float out towards Shelby County. Well, that doesn't happen anymore because this heat island is causing air to rise in the urban area of Louisville, and all the air that's rising there has to be replaced from some other location, so it's coming from the colder air around. So when they take off near the Gene Snyder, they started blowing or being sucked into town where there are not a lot of good places to land. So they had to start altering their plans and going out to different locations and getting farther and farther away from town to take off when they fly. Okay, so that's heat. I'm running a little long because I got diarrhea of the mouth today, but let's talk a little bit about winter weather because that's the season that's coming up. I'm not, in this case, giving you a winter outlook. That'll be coming. We could probably do that one within the next month. But this is the average snowfall in the U.S. Notice that we're in that 6 to 12 range for a big bulk of the Ohio Valley, but it does go dramatically, or it increases fairly dramatically as you go north. So Indianapolis gets a lot more snow, 18 to 24, almost 3 times as much as we normally do here in Louisville. When you look at the state of Kentucky, and again, I apologize to be so Kentucky focused on this one, but it was this email or this PowerPoint started out as a Kentucky-based one, and I just have to add some of these things for Indiana in here. But you notice that the highest snowfall amounts are going to be out in the mountains. We've talked about that, the higher elevations, et cetera. So 20 to 22 inches normally in a year. While here in Louisville, we're in the 14 to 16 inch range, and down south, Bowling Green, Hopkinsville, 8 to 10 inches in a normal year. But normal, as one of my daughters likes to say, is just a cycle on a washing machine. There's the average is a long-term average. Normal is considered a 30-year average, and but you can have variations from year to year. And here's just a couple of years variation. We're going to see from 2014 to 2017, I think here. Where if I go fast enough, you can see that each year. Try not to go too fast, I guess, because we're on a streaming thing here. But we have wide variations, but we can go anywhere from hardly any snow to 2015 when we shut down, one of the interstates was shut down, and 2016, the other interstate in Kentucky. 65 was shut down near between Louisville and E-Town with a big storm in 2015, and then Interstate 75 south of Lexington got shut down in 2016. So Okay, quick discussion of how to protect yourself against weather, and that's all about situation awareness. So now I'm going to break this off and just show you a couple of web pages here. Bring this all over. We're going to see mega millions, yeah. Now, what we're looking at is how to maintain good situation awareness, and the way to do that is to know where to find our information. Obviously, we want you to go to our webpage, weather.gov/Louisville. You can get there. The easiest way to get there is to go weather.gov and then just click on Central Kentucky, Southern Indiana as well. And we've got a bunch of information there, but it's mostly hidden. So what I'm going to do is show you a couple of things, and I'm not even sure where some of these are listed on here. So what I will do is send an email out to all the Weather Ready Nation ambassadors to give you access to these. Number one, we're going to look at how you can get your information to us, severe weather reporting form. We go out and train lots and lots of spotters each year, but we don't hear much from them. We've been getting a lot of our information from social media, but we prefer to have it come through this way because then it puts it into a nice tabular form. We can look to see where things are. It's not anonymous, and that's intentional because we have, through social media and through other means, we get anonymous reports that are, to be quite honest, bogus and made up, and there's just a sick element in society thinks it's really cool to put out misinformation, and we don't want to fall into that trap with severe weather reports. We do get a lot of people that, for whatever reason, like to let us know how much snow they've received, so our winter weather reporting form uses the same sort of format, and we get a lot more reports on that than we do from severe weather, but we want both of those. For those of you that have a .gov or a .org email address, you can access our request for weather support. We have to be real careful on doing anything with .coms for this, but if you should happen to have a large-scale event where you have thousands of outdoor spectators, you can submit this to us, and it puts it on our radar, literally. We click on it, and we'll see when things are coming your way. We'll send you information the day prior, and we're working on increasing our severe weather decision support services for that. We do have a couple of pages here. If you go down to the bottom of these one-stop severe weather forecasts, one-stop winter weather forecast, and one-stop drought forecast. I'll just click on the winter one here. I've got the severe weather one up there. But it puts in one page all the things that you're going to want to look at. Here, forecast ice and snow conditions, and then you've got the snowfall amounts being forecasted through there. Lots of good stuff on here. Town by town, you can look at the probability of winter precipitation. I don't know why this has numbers on it right now. It should be blank. But let's look at the severe weather one because we're not in any area that we're going to get winter weather here in the next couple of days, other than some frost. But you'll see on here we've got all the different warnings. You can click on all these hyperlinks there. You get the national impact or chart of activity, the severe weather threat, and lightning, et cetera, that are on there. Severe weather outlooks from the Storm Prediction Center. We've got nothing going on, so they're all blanket maps right now, which is nice. And then when we do have storm reports, you'll see them on here as well. And then for the forecast, you can access all sorts of great stuff here. Probability of precipitation, if you want to look at the maximum temperature, minimum temperature, the current temperature, or existing temperatures, and put all that there, you get that. So just on our regular web page, we'll go back to that. The thing that we do on a daily basis, just to keep you up to speed, is give you this weather story of the day. If there's something significant happening, there'll be a lot of real critical information on there. Otherwise, some days we do the next day or so because there's going to be rain. Other times we'll do 3 or 4 days or even 7 days just to give you what's relevant so you know what to expect. Our radar is always available there, and then we've got the other forecasts that are available as well. For those of you that are on Facebook, I have not been as active lately, but we do have our page, and our folks are very active. We monitor this all the time, so you can get to our page and see all of our information. You can ask us questions, send us messages on there, etc. And the same goes for Twitter. Let's see the new tweets so we don't get the mega millions. These are just people that we follow. We try to follow all the local news stations, and we get a lot of our reports unsolicited on Twitter, just when people post things, because we're looking for that information. And one of the things you can do is you can look for things like hashtag INWX. Type that in, anything that's significant about it, or when people have put hashtags out on Indianapolis or Indiana weather, it's going to show up here. And we'll get a lot of reports that way. The hashtag, 2-letter postal code, and WX is sort of an organic thing that came about, just people reporting weather. You know, days like this, you get shots of frost and stuff like that. So, let me see. I've got a couple things on here. We went longer than I was expecting by about 10 minutes, but I do want to open it up to questions. I'm just not sure if we're going to get barking dogs on this or not. So what I'm going to do is, if you want to, I'm going to unmute everyone, and I don't have a thing where I can unmute one person at a time, apparently. So I'm going to unmute everyone, and if you have a question, go ahead and ask it, and I'll be as honest and helpful as I can in answering. Okay, now you don't have to. Okay.
I unmuted mine.
And try not to step on top of you. Anyone? Bueller? Oh, no questions? I do have someone in the chat put down November 15, 2005, strongest tornado of the year hit Madisonville, Hopkins County. That's true. November tornado, we typically have the deadliest tornadoes in Kentucky are just like in the rest of Dixie Alley, or in Dixie Alley, occur in the wintertime. And they're more dangerous then because it's usually after dark. Some of the biggest tornadoes that we've had include the March 2nd tornadoes when West Liberty was hit in eastern Kentucky. That's also when Henryville was hit. That particular day, there were 39 fatalities amongst all the tornadoes. For some, I think 4 or 6 fatalities over in northern Kentucky, Boone, Kansas County over there. Any questions from anyone else? Otherwise, I'm going to go ahead and end this. We're going to our one last thing I'll show you is how to get to our YouTube channel. And that's at the bottom of our page here. If you want to follow us on Twitter, Facebook, or YouTube, just click on that. And I'm going to continue to YouTube, and we'll put this recording of this on our YouTube channel. There's some really cool stuff on there, just some of the videos that people have sent us. We haven't been using it nearly as much as we intend to in the future, but one of the things we have done on it and put on there is the online Skyward training, and we've got some other funky stuff on there with the Madison, Indiana, Ohio bridge explosion. I would suggest that you take a look at a couple of these tornado videos. The most recent ones, there's a great one from over in Harrison County, Indiana, that was just a couple weeks ago, or a couple months ago. I think it was in June, and smallest tornado I've ever seen, but it's really impressive. So check that out, and in under an hour, I'm going to go ahead and sign off now. Thanks, everyone, for coming in and sitting in on this. We'll send out just a short little blurb, maybe a 2-question survey, asking if you have any suggestions on when we might do this and what other topics you want to hear. But other than that, I appreciate you guys coming, and we'll catch you another time.